Hi people, once again. Now I am not here to discuss any more theory of the first chapter, sets. We are here to understand how sets is asked in the very question papers, in IITs, in CBSEs, every time. Today we are focusing on the IIT main based questions, as you can see. And now we are going to unfold the very first one. Let's see how it makes us whack our brains. The question says there are two events A and B. Basically two sets or two events distinct make the same sense. A is given to you as a distinct set and B is given to you as another distinct set. Which of the following is simple expression of this entire expression? Let me note this down for you. The expression given to us is A intersection B. This particular set is taken union with A intersection B complement. Remember, we had done three expressions in which complement of a set can be written. The second set is A intersection B complement. And the third set is A complement intersection B with the union sign. The question says, what is that set which you are going to obtain once you take the union of this set and this third set? The very fine, refined and easy way to understand this is through Venn diagrams. Let us try and draw Venn diagrams for each of these cases, and then eventually we are going to get what we want. The very first Venn diagram will be related to the first expression A intersection B. All of us know that if A and B are two distinct sets, then how is A intersection B represented? A intersection B is the common portion between A and B. Now this shaded portion here represents A intersection B. I am supposed to take the union of this shaded portion with which set? I have to take it with A intersection B complement. So let us draw another Venn diagram which is going to show us visually what is A intersection B complement. You all know that A intersection B complement means members which are sitting inside A and which are sitting inside B complement. But B complement has members means those members are not sitting inside the set B, and therefore A intersection B complement means all the members of A which are not sitting inside B. Do you remember anything from that? This was the very meaning of the difference of set A minus B. How do you plot or graphically in the form of Venn diagram represent A minus B? From A, remove the intersection, and what you will obtain is this. From the entire A, I have removed the contribution of B, and this yellow shaded portion gives me A minus B, also known as A intersection B complement. In the question, as you can see, A minus B is not written. What is written is A intersection B complement. You should be very thorough with the understanding of what this expression means, because if you get stuck, you won't be able to decode it as A minus B. What is the third expression? Now this shaded portion is again asked to be taken union with the third Venn diagram. What is it? The third Venn diagram is asking us to find out the portion which is represented by A complement intersection B. Now we all know that A complement intersection B can also be written as B intersection A complement. Why did I do that? Because intersection is a commutative operation and therefore A complement intersection B becomes B intersection A complement. And from this again we can conclude just in a similar way that we concluded that A intersection B complement is meaning that B is getting removed from A. Similarly, B intersection A complement means A is getting removed from B. So this turns out to be B minus A. It is now very simple to plot B minus A because we just have to remove the contribution of A from B, and that gives me this particular white shaded portion. This is the portion which has elements which are purely in B, and therefore I have obtained the very third portion which is B minus A. And now we just have to take the union of all three. Union of the intersection with the union of this shaded portion with the union of this shaded portion. Let's see what the resulting Venn diagram is. The Venn diagram that we obtain should have the intersection portion. That means this should be present. The next says this yellow shaded portion should be present. And the third one says this white shaded portion should be present. What is this? Isn't this the collection of all the members which are sitting in either A or B? This is what, my friends, is the very Venn diagram of A union B. This means if I collect all the members in the intersection plus all the members sitting purely in A plus all the members sitting purely in B, I am going to get all the members of A and B including the intersection. Let's see if this option is there in the four options. The first option, A intersection B, no, we don't want that because the answer is A union B. The second option is A union B, and this is the correct option. Option number B among the four options gets to be ticked. You are now supposed to copy this down quickly so that we move on to our very next question. Now, after understanding how, in what all ways can a set's decomposition can be given, this is what it said. This was a very smart way of decomposing a simple set in the form of three distinct sets. But what we obtained was the very first set that we learned in the creation of new sets, which was A union B. The next question waiting for us says that if universal set U is the set of three natural numbers 1, 2 and 3, set A is of two natural numbers 1 and 2. Now this is obvious that my set A is a subset of the universal set, in fact proper subset. Mind it, because 3 is sitting inside U, A does not have 3. Then it is saying, what do you think will be the complement of the power set of A? Here we are asked to find out the complement of the power set of A. Now you, just understand this, I am starting with solution number 2. My A is given to be 1, 2. And my universal set U is given to be 1, 2 and 3. We all know that set A is a proper subset of the universal set, correct? What do you think will be the case between these two? What do you think will be the case when I consider power set of A and power set of U? Try and think logically. A is a subset of U. If I diagrammatically show you, this is my A and this is my U. All the subsets of A sitting inside power set of A are those sets which are contained inside A itself. And subsets which are contained in A will automatically be contained in U. And therefore, every subset of A, suppose I have this as a subset, say subset C. If C is a subset of A, then obviously C is a subset of U also. In fact, proper subsets. Then therefore, I can say that the entire power set of A that I will obtain will have all the subsets of A. And power set of U which I will obtain will have all the subsets of U. But entire power set of A will be sitting inside power set of U, because every subset of A is also a subset of U. And therefore, the universal set for the power set of A is power set of U. What we obtain is this particular relationship. If A is properly contained in U, even power set of A is properly contained in power set of U. Now is the turn to understand what the question asks. Question is not asking us to find out power set of A or power set of U. It is just asking us to find out the complement of power set of A. For that, we should first find the power set of A. What is my A? I am given A to be equal to 1, 2. What all subsets can you think this subset A has? First of all, empty set is a subset of A because it is a subset of every set. Now, after borrowing nothing from set A, next we move on to borrowing a single element from set A, which we can do in two possibilities. Either we just borrow 1 or we just borrow 2. The next possibility is borrowing both the elements. That means completely taking the set A. And this means the entire set A is kept as the next subset, because you also know that every set is a subset of itself. Once these subsets are obtained, a set is formed of these subsets. That means a set is formed wherein each of these subset is an element. And this set is basically my power set of A. The next task is to unveil what is power set of U. Because my U is 1, 2 and 3, what do you think is my power set of U? Power set of U is the set of these subsets. First, borrow nothing, then borrow one element from which you get just singleton 1 or singleton 2 or singleton 3. Now start borrowing two members from you and you will get either this or this or this. This exhausts the possibilities, distinct possibilities in which you can borrow two members from U. After 2, we move on to borrowing all 3 members of U. That means which is complete universal set itself, because again every set is a subset of itself. This completes the possibilities in which I can borrow members from the universal set, because after this I would have moved on to 4 members borrowing, but U does not have 4 members. Now is the turn to verify this statement. Is power set of A contained in power set of U? Let's check. Is element phi inside power set of U? Yes, we have it. Is singleton 1 inside power set of U? Yes, we have it. Singleton 2? Oh yes, we have that also. And 1, 2, which is my set A, is also sitting inside it. Once you have the members which are sitting inside power set of U, you have this scenario. This is my power set of A and this is my power set of U. I am asking what is the complement of power set of A. You have to tell me all these yellow shaded members, because this yellow shading is power set of A complement, which means those members which are sitting inside power set of U but not sitting inside power set of A. The members which are there in power set of U but not in power set of A are singleton 3. It is not in power set of A. We just said these 4 members are in power set of A and they are marked white ticked. 2, 3 is not in power set of A. 1, 3 and 1, 2, 3. These are the 4 members which are not in power set of A but are in power set of U. And if I make a set of all these, which means of singleton 3, 2, 3, 1, 3 and 1, 2, 3. This set, my friends, is the very set of the complement of power set of A. Now that we have obtained this, it's time to go and check the 4 options. So let's just try and remember what we have. Singleton 3, 2, 3, 1, 3 and 1, 2, 3. Let's see. Singleton 3, 2, 3, 1, 3, the picture goes well by now. Then 1, 2, an empty set, no. And therefore A is definitely not the correct option. Singleton 3, 2, 3, 1, 3, 1, 2, 3. This perfectly matches with what we have and therefore B is the correct option. You can check that even C is wrong because it has phi in it and D is wrong because it does not have 1, 2, 3 in it. This is how we deal with the questions wherein if a set is a subset of the universal set, just this fact you have to remember that the power set of A is also a subset of the power set of the universal set, and then you can sail through the question. Note this down quickly so that we move on to the third question. Are we ready to just understand what third question is trying to bring before us? These concepts basically cannot be covered in theory. Therefore, there are questions asked which actually make you think, understand and see what all you can do with the questions. The third question that we have is as follows. Let U be the universal set and you are already given that A union B union C is the universal set U. And again there is this very dangerous expression which is this. This entire expression is equal to what? Let us try again the very approach of Venn diagrams and understand this question. This says, I am given that universal set is A union B union C. Why is this given to you? I am going to tell you a bit later. First, let us try and see which expression are we supposed to find. A minus B. After that we have union with B minus C. Union with C minus A. And once you obtain this set, firstly you have to obtain this set. After that is the question is saying, look at this prime symbol. That means you don't just have to find the set but find the complement of this set. This is what you have to find. For this, let us try and draw a big Venn diagram which can cover all the 3 sets in picture. Now we are given 3 distinct sets. This is my set A, suppose. This is B and this is C. Now what the question is saying is plot A minus B. Let's try and plot A minus B. From A, remove the contribution of B. Just remove B and you will be left with this. I am just avoiding B's portion from A, rest I am shading blue, and therefore I have obtained my A minus B portion. The next that the question asking us to shade is B minus C. From B, remove the contribution of C. What you will obtain is this particular portion. This portion is when I have removed C from B and obtained it. So this is B minus C. The third portion is C minus A. That means from C I have to remove the portion of A and I will get this. This is my C minus A. Once I have obtained all of them, the union picture of them is given to you here. Just avoiding this almost triangular region, I have obtained my A union B union C. Okay. Now the question is saying find the complement. Complement means avoiding the shaded region. What is the region that is left unshaded is the complement of all these three. The left out region you can see is this region and all of this outside. But now the question comes into picture. It is saying that A union B union C is the universal set. That means this complete blank portion does not exist. The universal set minus all these three sets, there is nobody sitting inside here, and therefore A union B union C is equal to the universal set, and avoiding the shaded region, the only region that is left is this particular region. What is this? This is what is A intersection B intersection C. And this is the very complement of A minus B, B minus C and C minus A. Because only this is left after avoiding the shaded regions. If suppose this particular fact would not have been given, that A union B union C is U, in that case this region which is A intersection B intersection C along with union which is universal set minus the A union B union C which is this blank portion would also have come as the answer. But here we don't need to worry because the answer is just this small portion which is A intersection B intersection C. Let us see if that is there in the options. The first answer is A union B union C. This is definitely not what I want. Second is A intersection B intersection C. Yes, this is my answer and therefore C and D, as you can see, are also wrong. Quickly note this down and understand the approach pretty nicely. Now we are in a position to unveil what question number 4 is giving us. Isn't this interesting, the approach to just visualize sets and your answers are there with you. Let us see question number 4. It is saying that the set A union B union C intersection A intersection B complement intersection C complement whole complement intersection C complement. Oh my God, such a difficult expression. But we need to understand what this difficult expression actually comes out to be, because it is asking what is it equal to. Let us try and solve this. The expression that we have is A union B union C intersection A intersection B complement intersection C complement. The whole complement intersection C complement. Let me remind you of something. For any number of finitely many sets, there was something like A intersection B whole complement was A complement union B complement, and we also had something like A union B whole complement was A complement intersection B complement. What were these? These were the very De Morgan's laws for any number of finitely many sets. Can you see something like that here? Of course, in this particular expression, I can take my complement inside individually to A, B complement and C complement at the cost of changing this intersection sign to union at both places. And therefore, what I obtain is A union B union C intersection A complement union B complement complement, and we know that any set's complement taken twice gives you the same set. And therefore, B complement, the whole complement is B, C complement, whole complement is again C, intersection C complement. And now, if you try and read these two expressions together, you will see that this actually turns out to be B union C union A intersection B union C union A complement intersection C complement. With the help of associative laws, I have put these brackets in both these expressions and clubbed B union C at both places. Now I am interested in using my distributive law, which says that this expression is going to turn out to be B union C union A intersection A complement, and just bring C complement as it is. Because once you open it, what will you get? B union C union A, which is here, intersection B union C union A complement, which is here. I have just used the distributive law, that's it. Now, you know that A intersection A complement, members which are in A with members which are in not A. Of course, there is nothing in common between them, and therefore this is nothing but the empty set phi. Once you take phi to be the union with any set, you know by the very identity law that the identity of B union C will not get hampered. B union C union phi is going to give you again B union C, and you will be left with intersection C complement. Just again use the distributive laws and open it up. This will be B intersection C complement union C intersection C complement. Again you've got the same picture, C intersection C complement. There is nothing common between them, and this set is empty set. Any set union the empty set gives you the same set by identity law, and therefore you get this answer as B intersection C complement. This tough looking expression has boiled down to something like B intersection C complement. We know that this is also equal to B minus C. Let's see what is given in the options, because among these two expressions, which is B intersection C complement and B minus C, any option will be the correct option. The first option itself is the correct option, which is B intersection C complement. If B minus C would have been given in the place of B intersection C complement, even then this option A would have been correct. Obviously option number B, C and D are wrong. This is when I am asking you to quickly note this down, the procedure and the technique to solve such difficult looking expressions by just the laws that we have done and bring it down, boil it down to such a simple looking expression. Meet you in the next question. After solving this difficult looking expression and making it into a tiny b minus c, let us see what the next question has for us. This is like a brainstorming exercise going on. Let's see the fifth question. This question says, suppose A is the set of all those tuples x comma y such that the y in the tuples looks like e to the power x, where x is a real number. Whereas in set B we have tuples of the form x comma y, wherein the y looks like not e to the power x but e to the power minus x. Then what do you think happens to the intersection and the union? For that we will have to understand first the intersection procedure. Let's write set A and set B. What is my set A? Set A is all those tuples x comma y such that the y given is e to the power x. That means whatever x is, e to the power same x is the coordinate y. And this x should belong to the collection of real numbers. Now if I say set B is all those x comma y such that the y is e to the power minus x, such that x belongs to the collection of reals. What do you think will be the intersection? If I want to find intersection of A and B, this means I want to find all those tuples x comma y which are there in A also and which are there in B also. How can a tuple be both in A and in B? Well, let x1 comma y1 belong to A intersection B. Okay, this means x1 comma y1 belongs to A and x1 comma y1 belongs to B also, right? Because x1 comma y1 belongs to A, therefore y1 is equal to e to the power x1 and y1 is equal to, because it belongs to B, e to the power minus x1. Isn't this kind of a contradiction? How can y1 be equal to e to the power x1 also and e to the power minus x1 also? That means such an x1 comma y1 will occur only if for some x1 e to the power x1 is same as e to the power minus x1. Because for then y1s will come out to be the same and the x1 corresponding to which both the y1s are same, that is going to give me the tuple belonging to A intersection B. That means my task is now to understand for which x1 e to the power x1 is same as e to the power minus x1. Let's start that. When do you think is e to the power x1 same as e to the power minus x1? When x1 is a real number. For which x1 or for which real number e to the power x1 should be same as e to the power minus x1? You know that a real exponential function is never 0 and therefore I can take it in the denominator. Okay, here I get e to the power x1 plus x1 is 1. That means I have just used the exponent laws and brought the denominator above. This gives me e to the power twice x1 is 1. And I know exponential raised to 0 is what gives me 1. This means if I compare both the sides, twice of x1 is 0, which implies x1 is 0. For x1 equal to 0, e to the power x1 which is 0 gives me 1 and e to the power minus x1 which is minus 0 again gives me 1. Therefore, the tuple 0, 1 is the tuple which is belonging to A also and B also and therefore belonging in the intersection. Which means A intersection B is non-empty. We cannot deduce much facts about the union and therefore the correct option that we have is that A intersection B is a non-empty set because there is an element 0, 1 belonging to A intersection B. It's now your turn to note this down by understanding every property that I have used of the exponential function and then we will move on to the next query. Moving on to question number 6, let's see what it has for us because then we would have brainstormed a lot. Isn't this interesting, all these questions? This is what is the pattern of the IIT main based questions. Let's move on to the 6th part. This says that suppose my U is a universal set containing 700 elements. Okay, I am already given how many members are sitting inside the set U. If A and B are subsets of the universal set such that number of members in A is 200, number of members in B is 300 and number of members in A intersection B is just 100. What do you think is the number of members sitting inside the set A complement intersection B complement? Remember the last lecture that we did in the set theory portion was this only. Based on the very fact of number of elements sitting inside the set, we had developed certain laws, certain rules, certain formulas. That is what you have to use over here to get the answer. Let's see that. I am given the number of elements sitting inside the universal set and therefore if I denote my universal set to be U, number of members sitting inside U is 700. So NU comes out to be equal to 700. Now I am given that A and B are proper subsets of the universal set and number of members in A is 200. Let's just copy that down. And number of members in the set B is 300. Now the question says, what do you think if the number of members in A intersection B is 100, number of members in A complement intersection B complement? Let's just write one more piece of information which is given to us. I am supposed and asked to find number of members in the set A complement intersection B complement. What is this number? You all know by the very De Morgan's laws. What were the De Morgan's laws? The De Morgan's law said that A union B whole complement is equal to, just take the complement inside individually to A and B and change the sign of union to intersection. This was the first law. The second law said if I have A intersection B and I am interested in taking the complement, then what happens is again the complement travels inside to A and B, but at the cost of changing the symbol of intersection to union. And what you get is A complement union B complement. These De Morgan's laws will be used to decode the number of elements in A complement intersection B complement. Why? Because number of elements in A complement intersection B complement is nothing but number of elements in A union B whole complement. We know that this can be written as all the set of members which are sitting outside A union B but inside the universal set. That means number of elements in the universal set minus A union B. And you know the very formula for this. This is equal to number of members in U minus number of members in U intersection A union B. But if A is a subset of U, B is a subset of U, even A union B is a subset of U. And therefore, what is the intersection? The intersection is nothing but A union B. And therefore, what I obtain is number of members in U minus number of members in A union B. Now, I am given that universal set has 700 members. So, I am just going to write here 700 minus, am I given the number of elements in A union B? No, I am not given that, but I know the formula for decoding that. It is number of members in A plus number of members in B minus number of members in A intersection B. The numbers becomes 700 minus, what is number of members in A? 200 plus number of members in B? 300 minus number of members in A intersection B, which is 100. Then what you get is 200 plus 300 is 500. 500 minus 100, you get 400. 700 minus 400, you get 300. And therefore, number of members sitting inside A complement intersection B complement is 300 members. Let's see if this is there among the 4 options. Can I see 300 anywhere? Yes, it is sitting right there at the 3rd option, and therefore C happens to be the correct option for this question. Quickly note this down, and if you have not revised the very laws based upon finding the number of elements in a set, just open that page before you and then you are going to sail through this question. I have already presented question number 7 before you. Just take a look and start whacking your brains and thinking what can be done with that. What do you think question number 7 demands you to do? Question number 7 is already giving you a set A and asking you the number of proper subsets of A. We all know if we have a set, what is that one result from which we can find the number of subsets of a set. Let me remind you that result. The result that we had was, which is directly used here, is the number of subsets of a finite set having n members. That means the cardinality is given to you to be n. Is 2 to the power n. How many members are sitting in a finite set? Then just take the power of 2 to that particular n and you will obtain the number of subsets of this finite set. We all know that in the set of subsets, only 1 or 2 possibilities can be present. Either the subset is strictly contained in the set or the subset is equal to the set. Just two categories. Now, if a subset is equal to the set, that can happen only when the subset is itself the set. Apart from this one subset which is equal to the set, rest all the subsets are proper subsets of the set. This means once you know the number of all the subsets of a finite set of cardinality n, just removing one from it is going to give you the number of proper subsets in the same set of cardinality n. And therefore, with this understanding, I am writing the number of subsets in a set of cardinality n, or maybe I should write here proper subsets. Once you know the total number of subsets, finding the number of proper subsets is not a task. What you do is, you just reduce 1 from the number 2 to the power n and obtain the number of proper subsets of set A. This is the very result which we are going to use to deal with this question. Here set A has exactly 5 members. My A set is finite with cardinality 5. Therefore, if I write that total number of subsets of A is equal to 2 to the power 5 by the very use of this result. By 2 to the power 5, what do I mean? This is 2 into 2 into 2 into 2 and again. This number is nothing but 32. I am not interested in total number of subsets. The question is saying, give me the number of proper subsets. This means this extension of the result is going to come into play and I am just supposed to reduce 1 from 2 to the power n. Thus, total number of proper subsets of the set A is 2 to the power 5 minus 1, which means 32 minus 1, which is 31. This is when I have the total number of proper subsets of A. Let's find out if 31 is there in the options. Well, it's right there sitting at option number C, and therefore 31 is correct. Option number A, B and D are wrong. Quickly note this down and be ready for the next question. Now, I will be presenting before you the 8th question, which is frequently asked in the IIT mains exams. The pattern is all the same. Just practicing these is going to give you a good command and techniques of dealing with the questions in the IIT. And now, we are all braced up to understand the 8th question, which says that if A and B are two sets, distinct sets, what do you think is the set B minus B minus A? Is it equal to A minus B minus B, which is first you obtain A minus B and then subtract B? Or is it A minus B or A or B? Let's try and find out. Solution 8 says B minus A is what I have to obtain. Let us now take help of the Venn diagrams because these are arbitrary sets given to you. If suppose the sets would have been defined, we would have jotted down the elements and used the definition to get what this equals to. Let's start with the Venn diagram. I am plotting my two sets A and B in a very general scenario. The expression says B minus A. Firstly, I am going to shade the B portion. What is my B portion? This is what is the entire set B. Then I have to remove B minus A from B. How do I remove? Basically, B minus A is this portion. From the entire B, just remove the yellow shaded lines and you will be left with this. That means this is obtained once from the set B I subtract the set B minus A. What is this? These blue shaded lines actually are nothing but the representation of A intersection B through Venn diagrams. And therefore B minus A, just remove the extreme right portion of B, you will be left with A intersection B. But I am not given A intersection B anywhere among the four options. Can you see A intersection B anywhere? No. That means you will have to decode what all these sets also are trying to say. If any of these sets turn out to be A intersection B, that option will be the correct option. Now obviously C and D are at mostly wrong because A and B is not equal to A intersection B. But an expression which is matching to B minus A is A minus B. Intuitively, I feel that maybe B can give me the same answer as the expression given in the question. Let's try and see what A minus B gives. Again, taking the help of Venn diagrams, I am given two distinct sets A and B. From the set A, let me shade A for you. This is my entire set A. From A, I have to remove A minus B. How do I remove A minus B? Is I just cancel this white shaded portion. But still, there is some blue portion left without being cancelled. That is the portion which is left once I have removed A minus B from A. And that portion is this yellow shaded portion. What is this? What did I do? I just, from my set A, removed the set A minus B and obtained this set. What is this yellow shaded portion? This is nothing but again A intersection B. This is what I wanted. And so you have to use your intuition also sometimes, which is I just use the fact that if I replace B by A, maybe I am going to get the same result. And therefore, option B turns out to be the correct option among the four because both of the expressions give A intersection B when solved. Note this down and understand the technique in which I have used Venn diagrams in solving this question. And now we are all braced up after understanding how much the Venn diagrams actually help in solving difficult looking expressions and making them cakewalk for you. Question number 9 says that you are already given a universal set which is closed interval 1, 5. We all had studied what closed intervals are. Inside this, you collect all those real numbers which are greater than or equal to 1 and less than or equal to 5. The entry of 1 and 5 is allowed in this universal set. The question says, if I have a set A, which is all those natural numbers which satisfy this equation, what do you think is the complement of A? These questions are very famous questions. The student looks at it and gets scared, but they are very easy, trust me. Let me show you how it's done. Let me write my set A, which is collection of all the natural numbers which satisfy the quadratic equation x square minus 6x plus 5 equals 0. So firstly, in order to decode and work with A and find its complement which is asked in the question, we should be aware as to what are the members sitting inside A. Can we find out those members? Basically, finding the members of A means all the x which are satisfying this equation, which means all the roots of this particular quadratic equation. And this is when the 7th standard mathematics comes into picture, because x square minus 6x plus 5, when we break the middle term, by that technique we will very easily get the roots. This equals 0, just break the middle term. This breaks to be minus 5x minus x plus 5 equals 0. Because minus 5 into minus 1 gives me 5, which is the constant term, and minus 5 minus 1 gives me minus 6, which is the coefficient of x. Now just collect the like terms. You get x common, x minus 5 minus 1, x minus 5 equals 0. This means the factors are x minus 1 and x minus 5. Therefore, x equals 1 and 5 are the very roots of this particular equation. Thus, my set A is 1, 5. If I know that the universal set is the closed interval 1, 5, which is given to you, and I have to find a complement, which means from you I have to subtract A and see what I am getting after doing that. Let me draw a small number line before you. Suppose this is 0, this is 1, 2, 3, 4 and 5. My universal set is including 1, 2, 5, this entire portion. This is my U. I am taking 1 also, I am taking 5 also, and all the numbers in between also. From the universal set, if I remove A, that means I will have to remove 1 and 5. That means just remove 1 and remove the endpoint 5. What you are going to get is all the numbers strictly greater than 1 and strictly less than 5. Here the entry of 1 and 5 is not allowed, and therefore after doing that, U minus A comes out to be all those x belonging to the collection reals such that x is strictly greater than 1 and strictly less than 5. What is this? Isn't this the very definition of the open interval with the endpoints 1 and 5? This is what is the answer, because U minus A is nothing but a complement, and therefore after removing A from the universal set, which is the closed interval 1, 5, I have obtained the open interval 1, 5. Let's see if it is there in the options. Option number A gives me set 1, 5. Yes, this is my set A. Of course, we know this was the set A that we obtained, but I am wanting a complement, and therefore I cannot mark this as the right option. Option number B gives me what I want, because yes, A complement is definitely 1, 5. Closed interval 1, 5, well, this was the universal set, and option number D, well, that's definitely not into picture. And therefore, this is where I end this question number 9. Note this down by full understanding. After dealing with question number 9, now we come to our very last question. And this is going to emphasize on the importance of the concept of finding number of members in a particular set. The question says that if you have A and B as two distinct sets such that number of members in the set A is 115, number of members in set B is 326, number of members in A minus B is 47, and the question is asking us to find the number of members in A union B. So much of information is given to us. Let us just write it down all together and then proceed with the solving part. We are given number of members sitting inside set A to be equal to 115. Number of members sitting inside set B is equal to 326. Number of members in A minus B is 47. And then I am asked to find out number of members in A union B. If I directly recall the formula of number of members in A union B, I know that number of members in A union B is number of members in A plus number of members in B minus number of members in A intersection B. In order to find this, I should be having number of members in A available, number of members in B available, and number of members in A intersection B available. But I am only having number of members in A and number of members in B. This particular portion is still in question. I don't know how many members are there in A intersection B. Once I come to know this number, I will just be supposed to jot this down, all these three numbers over here, just calculate and find out the total coming to be the number of members in A union B. The task now is therefore not to find A union B numbers, but to find number of members in A intersection B. And who is going to help us in doing that? The third piece of information, which is number of members in A minus B. We know that number of members in A minus B is equal to number of members in A minus number of members in A intersection B. Because you just have to remove the common portion from A and then you will obtain A minus B. What is the number of members in A? Well, A has 115 members. Number of members in A intersection B, I don't know. But yes, I know number of members in A minus B, which is 47. And therefore, number of members in A intersection B turns out to be 115 minus 47, which is going to give you 68. Once I have number of members in A intersection B with me, I am just supposed to plug this value over here and I will be obtaining my number of members in A union B. Let's do that. Number of members in A union B is number of members in A, which is 115, plus number of members in B, which is 326, minus number of members in A intersection B, which we have obtained to be 68. And this very simple calculation is going to deliver you 373 as the answer. Let us see if we have 373 as one of the options. Option number 1 is 372. No, that's wrong. Option number B is 373, which is correct, and therefore C is wrong, and obviously none of these is wrong because B is the correct option. This is the importance of finding number of members sitting inside a set. You are supposed to note this down and be thorough with all the 10 questions that we have done, because practicing them is going to make you a master and you will be thorough as to how to proceed with attempting questions in IIT Main. We'll meet you next time, so be braced up, pull up your socks, and till then, take care.